set is called as EDA. Okay. In normal terms, we also call this as exploratory data analysis. Okay. Now, this EDA is also called as data wrangling. Okay. Now, what is the significance of this data wrangling? Why do we perform exploratory data analysis? First, we will understand that, and then we will move towards the, let's say, practical direction. What is data wrangling? Let me tell you, whenever we receive the data, it is always in the raw format. Okay. When I'm saying data is in the raw format, which means there is a possibility that it is not structured in nature, not in the correct format, maybe having the different data types, okay, or not the correct data type which is supposed to get. Now, when we receive the raw information or raw data, first what we do, we try to understand the data, okay, by looking at it, by understanding what type of feature it contains, how many number of observations are there, what is the shape of the data, what is the size of the data, things like that. And we call this thing as data exploration. Okay. Once data exploration is done, what is data exploration? As I told you, understanding of data, right? How, what are the insights? What type of feature it is containing? How many number of features are numerical in nature? How many of them are string type of data? Such type of understanding falls under the category of data exploration. Once the data exploration is done, we move towards data cleaning. Okay. Once we understand what is the data, what it is type of, we jump into the next part, which is called data cleaning. Now, what is the cleaning of data? We need to understand that raw data might contain duplicate type of entry. And when I'm saying duplicate type of entry, which means I'm talking about both rows and columns. Okay. So first we'll try to remove duplicacy from the column side, and then we will try to remove the duplicacy from the row side. And I'm saying something is duplicate, which means something is identical in nature. Okay. Which means it carries the same meaning, same type of entries. That's when we call the data duplicate in nature. Now, handling missing values. When I'm saying missing values, which means there is a possibility that in your data set, having a tabular-like structure like this, these are features and these are your observations. All the observations are filled. Maybe there is a possibility that one or two cells are empty. So in such cases, what we do is we perform imputation of the data. We're saying imputation, which means we try to fill the null values of the data set. Okay, so handling missing values, there is a possibility that we can perform imputation, which means we are going to fill that empty data set. Another possibility is that we are going to delete the row or column. Okay, so we need to understand what, on the basis of what all situations we are going to delete the entries or columns, and on what conditions we are going to perform the imputation. Once the data cleaning is done, we do data pre-processing. Data pre-processing usually people learn in machine learning. Some of the data pre-processing you guys are going to learn here as well. I'm saying data pre-processing, which means, yes, we are going to do all of these things with the help of Python. Okay. So when I'm talking about data pre-processing, which means what? We are going to convert the data in the correct format. Now I'm saying format means what? There is a possibility that one column containing let's say, string type of entry, but it should be number type of entry. So what are we going to do? We are going to change the format of the data into its correct form. So that is what called as data pre-processing. Some of the data pre-processing we do here while performing exploratory data analysis. And rest of the data pre-processing we do while performing the machine learning algorithms. Why is the reason? Because there are some different demands for both of these processes. While we identify some of the mistakes or pre-processing steps or measures here in the EDA, we understand some of the steps and measure according to the algorithm in machine learning. Okay, so it is half and half, 50-50 process. Some of the pre-processing we are going to do here. Once the data pre-processing is done, we are going to perform analysis on the data. When I'm saying analysis on the data, which means we are going to solve the business questions or issues. We are going to see that what is the highest profit, what is the highest loss, what sales we are having. Okay, in our case of loan data set, we are going to judge how many people got the loan, how many people got rejected from the loan, what was the reason behind that. All of the thing falls under the analysis category. In MS Excel, how we perform analysis with the help of filtering the data out, performing group by on the data, joins on the data. These kind of things we are going to do in the analysis section. Once your analysis gets done, then we jump into the machine learning model. So whenever you receive the data in your hand, it is never going to be in the correct form. Okay. It has to go through these steps of parameter before putting that inside the machine learning model. Okay. So we have to follow these steps, then we are going to fit my data inside the ML model. So the process which we are performing here, starting from the raw data, ending at analysis, called as EDA, exploratory data analysis, or data modeling. Okay. Why we do data modeling? What is the reason for performing data modeling? Do you understand that if we have garbage, okay, since we are having the raw type of data, which means it contains some garbage, but it is not in the correct form. There is a policy called as garbage in, garbage out policy in the Python, also in the machine learning. If you put garbage or if you fit garbage data inside the machine learning model, it is going to give you the garbage efficiency of the model. So there is a necessity to perform this EDA to put the data in the correct format to remove the garbage from the data. Then only we can perform machine learning modeling, which will give me the higher accuracy or let's say the higher performance. Okay. So because you understand that, right? Whenever we are having the raw data, it does not carry any sort of pattern. There is no pattern. We have to create the pattern. And it has no feature. Feature when I'm saying, which means characteristic. I'm not talking about column. Okay. It does have column, but it does not have any sort of characteristics. So we are going to create the pattern by putting the data in the correct format so that we can make the use of its characteristics whenever required. Okay. We already loaded the data inside the Jupyter notebook, right? Now we will go that in the practical section and we will start from the data exploration. Okay. Meanwhile, are we okay with this particular data wrangling journey? Do you have any sort of question from any part? Data cleaning can lead to the loss of data. No, that's what we are going to understand. When we are going to clean the data, which means we are removing the anomalies from the data, duplicate values, there must be some missing entries. So we are going to deal with that missing entries. If I'm going to delete with those, delete the cell with those missing entries, what will happen? It will result in the loss of data. So in that case, we perform imputation. Okay, imputation means statistically finding the correct value to fill in that blank space. Okay, so it will not lead me to the loss of data. Getting it? And guys, please do change your chat settings because I can see your friends will unable to read your chats as it is not to everyone, it is directly to me. If my data set is massive and there is null value somewhere, I can view it. How will I know if I want to delete it or include it? Okay. So this is what there is the thing when statistics comes into the picture. Okay. I cannot decide this on my brain and we cannot deal the data according to our mood as well. Okay. So we call this a statistical approach. First, we will understand the data with the help of data exploration. After understanding the data, then I am going to decide, do I need to perform imputation or I need to move forward to deleting those entries? Okay, so if you are having the massive data or even you are having the small data set, we will move forward with the statistical approach for cleaning it or performing the imputation. As this data cleaning section comes into the picture, we will have the deep discussion on that. Okay. Anything else? Okay. So if nothing is there, let's move forward and let's talk about the data set which we imported yesterday in the Jupyter notebook, right? I'm cleaning as we reading this. This is pandas Jupyter notebook. Let me run all the cells first. Okay. Okay. Now guys, here you can see I stored my data set in the df1 variable. Yesterday somebody was asking me, do I need to close this file? I told you that it is not required. What was the reason behind that? It is not acting as an object here. It is just a copy of the data set, and we are going to work on the copy of the data set. Once you are sure, once you are done formatting your data, putting the format in the correct, let's say, use or done filling the null values, data cleaning, data formatting, everything is done. What you can do is you can again save the copy of this data set in the different file format. Okay, so this is what we can do. It has no correlation with your original data set. We don't have any sort of bridge between them. Okay, so it is just a copy of your data and we are going to work on the copy. Now, I will show you one thing that right now we are dealing with the comma separated value. Everybody knows that. Now, where is my lone CSV file? I'm searching that file. I want to show you something. Wait a minute. MNO, right? This is list. Known data sets. Let me get open. Okay, don't you guys have CSV file? I shared that yesterday, but let me do that again. Give me a moment. I hope you guys know how to import it, right? I've given you the steps yesterday for importing the file. Then the PQRS. Let me search it here. Known dataset CSV. This is your file. I'm dropping the file in the chat box. You can download it and import it. Okay. Yeah. So what I was talking about, see guys, I opened the CSV file in the normal CSV format in the Jupyter notebook. It is not here in the notebook where we are performing the pandas thing. No, we opened the file in the separate text file format. Now you can see what is the separator here. Every entry here is separated with comma. That's why we call this as comma separated value, right? Now, do you understand that the extension itself is telling me that the separator here is comma, right? Comma separated value, which means the separator here is comma. Now, there is a possibility that this separator could be anything, but the file still contains the extension as CSV. Okay, there is a possibility that this separator could be a line, okay, dollar, percentage, or any special character. Because whenever we perform data extraction or whenever your data engineer perform data extraction, they are not aware what type of separator to choose, right? So there is a possibility that the extension of file is comma separated value, which means CSV, but inside that file, the separator could be anything from the combination of any special character. So in that case, if you try and import that data set, normally the way we have done before, it is not going to convert your data into the tabular format. Getting the point, what I'm trying to say? Let me repeat that again. If the separator here is other than that of your comma, okay, and still you're trying to import the file like this, it is not going to convert your file into the tabular format like this. It is going to put all the entries in the single column. And that is what we don't want. So even if the extension of file is comma separated value, there is a possibility that the separator inside the file could be anything. So we have to prepare in such a way that it can convert my data into this tabular form with any of the separator having inside it. So what we can do is we can simply mention the separator section here. We do have a choice. Suppose your separator is a line, which means every entry inside your data set is separated with a line. The extension still remains the same. Don't think that extension is going to change. The extension is same, it's just the separator inside the file is going to change. So suppose if I write the separator like this, a straight line, and suppose I'm running this cell, you can see it is putting all the data into the single line or column. It's not converting into the table kind of a structure. Because as of now, my separator is not a line, it is comma. So you can mention the separator here as comma or line or whatever to convert your data in this format. But by default, if it is a CSV file and the separator is comma, you don't need to mention it. It is just one of the parameter present inside the read underscore CSV. Okay, so we are understanding what are the different ways of importing the data. There is a possibility that we have to import the data according to our requirement, right? Some of the, let's say, I don't want whole data. I want a chunk of data, let's say 50 rows and 12 columns. Such type of combination we also want. So this read CSV gives you this opportunity. We do have different arguments present inside this read CSV that will help you to import the data according to your requirement. Okay. Do we have any questions on this? Is separator clear to you guys? Okay. Once you understand separator, now we are going to jump into the indexes. Okay. Now what will happen? Some of the times while importing the data set, client already mentioned that any of the column from your data set, you can create that column as your indexes or index of the data. So let me write it down. How to create any feature as the index of the data set. Okay. So for that purpose, again, I am copying this read CSV. Look into the thing very carefully. I'm just copying the command. I'm not copying the variable. I'm just keeping my variable as it is. Okay. I'm just showing you what all possibilities we have. But we are sticking to this importing part only. Okay. We are going to work with df1 only. So that's why I don't want you guys to touch this df1 variable. Let's see another cell and perform different arguments on this just to see what it does. Okay. Now, suppose I want to create some particular feature as the index of my data set. I can simply write index call and I'm going to mention that particular column inside it within the square bracket. As you can see, which one which of the column I can create as index. So do you understand one thing? Yesterday we had a discussion over this loan ID where we were talking about the uniqueness of the entry, right? Uniqueness when I'm saying, which means every loan ID is unique in nature. No two customer can have the single loan ID, or let's say similar loan ID. Okay, there is not a possibility that me and Vishal carry the same loan ID. It is not possible. It is same as that as of your roll number in the university. You know that your name could be identical, but your roll numbers couldn't be. Okay. So in index call, I am mentioning my loan ID to be the index of my data set. Just pasting it down, running it. Look into the data set which we imported previously, and now look into the data set we are going to import right now. Previously, the default index was 0, 1, 2 up to 6.3. Now here you will see I changed the index of the data set. Now it is creating my loan ID as the index of my data. Look into this very carefully. I'm not saving this into some variable. It is just normal command running to show you guys how you can create any column as your index. Getting it? Any questions? Are we good? No, you cannot create row as the index. Do you understand that, Jayashri? What is index? Indexes helps you to identify the rows in a table, right? So this is helping me to identify the row in a table. And I cannot create one row as my index. So indexes are for separately row section and column names are for column section. So we cannot do this for rows. We can only do this for column. Yes, like your serial number. Okay. Can we later retrieve the feature used as index? Yes, we can reset the index as well. Okay, you will see that later. There is a possibility that we can reset the index once my job is done. Okay. We'll see that with time. Don't worry. Okay, this is your previous one. The first feature is changed to gender now. Yes, correct. Now, if you try and extract the first feature of your data set, it is now the gender, not the loan ID, because we already created loan ID as the index of my data. Okay. Any more questions? Shall we move forward? It removed column of serial number. No, guys, do you understand that we don't have any column of serial number? You can see it is just by default index number provided by the pandas for you guys to understand that these are the separate rows. Okay. So if there is some column of serial number, there should be some name right above it. But we don't have any name. Okay. So what we have done by default, the index is going to look like this. I just changed the index from that to this one. Okay. Previously, there was no index, just normal serial numbers. Now I just changed that serial number to the loan ID. Okay. Yes, any more questions? So let's move forward. Let's talk about how to extract some set of rows and columns. Okay. Suppose you are having the data, okay, and you don't want whole data set to be extracted. You just want some of the rows and some of the columns to get extracted. So again, I'm picking the same read CSV line, pasting it down right here, keeping the index call as added as it is, putting one comma here for the selection of columns. I just want to select some particular column. I'm going to simply write use calls. Okay, equals to, in these square brackets, I'm going to mention the name of the columns which I want to extract. Let's say married, putting one comma, education, putting one comma, and self-employed. Okay, running this. Wait a minute. Okay, I have to save it. Just remove this part and work this. Okay. So it was unable to pick that up. I have to save this in some variable and reuse that variable. That's why it is creating problem. So don't worry. You can do this one by one. First, set the index, put this in some variable, and then later try to extract the columns out of it. Okay. So now you can see married, education, self-employed. These three columns are extracted out of the whole data set. And we do have all the number of rows here. Okay. Now consider you want to extract first 50, first 100 rows. Then you can take the help of n rows. Okay. N rows equals to, let's say 50. That is going to extract first 50 entries for you. You will see first 50 entries. Okay. If you want to extract first 30 entries, you can simply write n rows as 50. It's going to extract first 30 entries for you. Okay. So this is how you can select particular rows and columns while importing the data set. Making sense? Shall we move forward? You are jotting it down. Okay. Now the last thing, we are right now talking about importing of the data only. I'm not going in some data exploration part. It is just I'm showing you whenever you get choice or whenever you're having some situation where you want to extract the data like this, we have a flexibility. Okay. Now, we do have a standard practice of keeping the copy of the data. Since you guys can see that there are so many parameters available in the read CSV format, and suppose I use all of these parameters and later extracted or imported my data set, and accidentally I make some changes in the data set which is not required. So do I need to again perform the importing of the data like this with this much of manual effort? No. So for that purpose, we always create a copy of the data as we do. Okay. So you can see the correct format which I wanted to import was DF1. So what I'm going to do is I'm just going to create a copy of the DF1 dataset. So if my original dataset gets disturbed or accidentally modified or manipulated, I can use the backup. Okay. So copy of the data you can directly create. DF1 is my original variable where I imported the data set. I'm going to simply write dot copy. If you guys remember, we do have dot copy method for every data type. Right? So df1 dot copy will create the copy of the data and I'm storing that in df2 variable. So if you check your df2 variable, it is going to look the same as that of your df1. So that is how we can create the copy of the data as our backup plan if we accidentally do some manipulations which are not required. Okay, tempering the data, let's say. Okay, so the importing of the data is done. Now we will talk about data exploration. Okay. So these are the basic steps for importing your data set. Now we will jump into the next part called as the data exploration. If you guys have any sort of question, guys, you can again drop that in the chat box. We do have time for that. Data exploration. Okay. Now this data exploration have two subdivisions. First one is your, let's say, high level understanding. And another one is your low level understanding. Okay. Now, what is the difference between this high level understanding and low level understanding? Let me tell you, high level understanding says that what all commands we are going to apply is going to get applied on overall data set, which means if I want to find the mean of the data set, I'm going to find mean of all the columns altogether. If I want to find the mode of the data set, I'm going to find the mode of all the data set, all the entries altogether. That is what we call it as high level understanding, where we are applying the commands on overall data set. Now, let's talk about low level understanding of data. What is low level understanding? It says that we apply the commands on the combination of columns. Previously, it was happening on whole data set. Now it is going to happen on the combination of columns. Okay. So let's say when I'm saying combination of column, it could be univariate. It could be bivariate. And it could be multivariate as well. Okay. So when I'm saying univariate, bivariate, and multivariate, basically what happens? Univariate says that We are going to apply the command on this single column, one column at a time. When I'm talking about bivariate, we are going to perform the commands on two columns at a time. Now, do you understand that what all two columns I'm talking about? Let me tell you later. Multivariate matlab combination of different columns, two or more you can say. Okay. Now, guys, this is very important interview question. And what is univariate, bivariate, and multivariate analysis? Okay. So you have to tell them that whenever we explore the data, whenever we perform data analysis, we take the combination of different columns to understand the data or to find the insights from the data. Then we perform univariate analysis, which means applying the commands on the single feature, understanding the single features of the data set. Bivariate analysis, combining two combinations of different columns for understanding the insights of the data set. Multivariate analysis, that will help us to perform the analysis like in function in the data, perform feature engineering. Don't worry. Once we will cover this topic one by one, you will get enough of the lines for defining these three low-level understanding techniques. Okay. Do you understand that? Now, let's talk about high-level understanding of the data. Let me change the heading. High-level understanding the data. Okay. Now, what all commands we are going to apply that is going to happen on overall data set. Okay. So the first command is checking the head of the data. Simply, if you mention df1, which is nothing but your dataset name, and write dot head. Okay, run it. What do you guys think? What it is giving me? What head is doing? First 5 observations, right? First 5 entry of the data. Why is that? What is the reason behind that? Why do we check first 5 entries or first 10 entries? To understand the type of features we are having. Okay. Simply, we check first 5 entries. It's, let's say, loan ID. Okay, there's some alphanumeric number or type of value. Gender, it is definitely string type of value. Married, string type. Dependence, not sure. It could be string or it could be number as well. But we have to check. Education, string. Self-employed, string. Applicant income looks like integer. Co-applicant looks like float. Loan amount, float. Loan amount term, float again. Credit history, again not sure if it is string or float. Property area, string. Loan status, string. So this will give you the understanding the type of data your feature is carrying. Okay. Now the other thing which we do is finding the tail of your data. Suppose if I'm writing df1 dot tail, it gives me the last 5 entries. Okay. What will happen for the last 5 entries? Last 5 entries helps me to check the garbage entry. Okay. Usually we say that most of the garbage comes at the bottom of the data set. Okay. Most of the garbage settle down at the bottom of your data set. And that's why we check the tail of the data if there is all the values present to be as null. There is high probability of this thing to get happen. Most of the time, whenever we check head, we always try to match it with tail. The type of entry my head is containing, my tail is also containing the same type of entries. Or it is containing all the entries as null. Okay. If the null entries are there, we'll try and remove those null entries. That we'll learn later how we can do that. But if we are not having the null entries, if we are having the same type of entry or set of entry, which means my garbage does not, my data does not contain any sort of garbage in its bottom. Getting it? So that is why we find the head and tail of your data. Once you're done finding head and tail of your data, then we write df1.dtypes. Now you can see it is giving me the data type of every feature, where object is signifying to the string type of data. Here, usually we call this as categorical variable or categorical feature. Integer and float signifies number, or we call this here as numerical type of feature. This object again is feature. Okay, so either it is categorical or numerical. There are only two possibilities of a feature to be. Categorical means string type, numerical means number type. You can see dependence is string type of data. Previously, it was looking like some weird number. Got the clarity? Property area. Credit history is also float. Okay, so it is not string type of data. And that you can check and analyze every feature. Okay, what data type it is carrying. Okay. It is there is date in one column. What is the D type of that? Date time. Okay. If we have a data type containing, we have a feature or column containing date or time in it, the data type of that is going to be date time ns. Okay. Nanosecond is same. We will learn about this separately. Okay. We are going to have separate 1 hour session for date time series, time series analysis. Okay. The next command, you can see guys, we are applying the commands on whole data set. I'm not picking the columns as of now. I'm applying the commands on whole data part. Okay, data frame. So if I'm going to write df1 dot describe and run it, you can see what it is giving me. It is giving me the statistical view of your data set. It is going to pick up all the features of your data and give me the statistical approach. But look into this very carefully. Is it picking all the type of data? Is it picking all the columns? I can only see 5 columns here. On the basis of what? Only numerical it is picking. Okay. So now this is your job to be that attentive to understand that we can only have, let's say, this statistical calculation for the numeric type of data. We cannot find these statistical calculation for the categorical features. We have some another view for statistical. We have another view for categorical feature. If I want to find a statistical thing for that, it could be mode or something different. Not going to match with the numerical one. Okay, so we have to deal the data type separately as well. So keep that in mind. This all things you can only find for the numerical column. Okay, not the categorical feature. So first, what is the first one? The count. It is telling me What do you guys think? What the count is telling me? Sure. You guys are sitting and relaxing too much. Let's have a discussion. Wake up. What do you guys think? What is the count telling me? Number of entries? Yes. Number of rows and observations. From here, you can also understand how many null values are there. Overall, we are having 614 entries, right? And out of that 614 entry, applicant income contains all 614 entries, which means it is filled, right? No null values. Co-applicant income, again, no null value. Loan amount, 592 out of 614, contains null value. 600 out of 614 contain null value. 564 out of 614 contain null value. These are filled properly. These columns does not have null entries, but these three have null entries. Okay. Now, what is the mean? It is picking up this applicant income overall entry and calculating the mean. Okay. Every entry present in that column is getting picked up and it is calculating the average of it. And you can also say that average of that particular column. Okay. We can only find the average for the numerical feature, right? If you guys are not sure, how you're going to find the average for the categorical feature? Not possible. Okay. Standard deviation. We already had a discussion. What is SLD yesterday? Minimum. What is minimum? Minimum value in that particular, yes, lowest, least value, you can say. So whatever the least value in each column, it is going to give me that answer. Okay. What is 25% of the data set? It is quartile 1. Okay. What is 50%? It is quartile 2. What is 25%? It is quartile 3. Okay. So why we are talking about this quartile 1, 2, 3, 4, we will going to learn that later. Don't worry. This quartile helps us to first, basically, we need to understand how it is calculated. 25% of the data. So basically, it is sorting your data first, okay, and then calculating the percentile, or percentage, okay, percentile of it, and then assigning it to 25%, then assigning it to 50%, then assigning it to 75%. Don't worry, we'll learn that later. Okay, so these all are quartiles. We say that 50% or quarter 2 is also called as median of the data. Okay, getting it? So 50% is also considered to be as the median of that particular column. Let me ask you one question. Applicant income is numerical feature, right? Everybody understand that? In NumPy, we were talking about the randomness of the data, right? If it is biased or unbiased in nature. How we check that? With the help of standard normal distribution. Now I'm giving you some certain conditions. How you identify if the data is biased or unbiased. What do you guys think? This applicant income is biased or it contains some sort of entries which is disturbing my average? What do you guys think? Applicant income is equally distributed or biased in nature? What do you guys think? Hmm. What I told you guys, how you check if data is biased or normally distributed. Your mean should be equals to your median, right? Mean is 5403. What is median? 3812. Are they two equal? No. Data is biased, which means it contains outliers. Don't worry, we'll talk about that. Okay. Now let me read the questions from the chat box. Since this is finding the central tendency of each feature, isn't this is low level understanding? No. You can see why we are calling this as high level understanding. I'm applying the command on whole data set, right? DF1. It's the property of the describe to pick up the feature and give me the analysis of the particular feature one by one. Okay. If I'm going to select only applicant income and then get the statistical view of it, then it will fall under the low level category. Right now, I'm applying it on the whole data set. That's why it is high level understanding. Okay. 25 percentile of what is greater than maximum, minimum, or total. That we will see. Okay. Shri, this is something which we will learn step by step. Let's not hurry. There are so many things to capture. Now, since we understand this particular df1.describe thing, don't worry, we'll talk about the outliers later. Okay. I was saying that this data is biased in nature. Applicant income is biased column. We will talk about that. Don't worry. Now, suppose I want to get a statistical view of the categorical feature. So can I simply write df1.describe include object? Okay. So now what it is doing, it is giving me the entry of all object type of data. Okay. Loan ID, gender, married, dependents, education, self-employed, property area, loan status. Now, count is again telling me the number of entries present in that particular column. Unique is telling me how many unique type of elements are there in that particular column. You can see it is telling me we have a 614 entries and all 614 entries in the loan ID is unique in nature, which means we made perfect index. Okay. Gender. It is telling me that we have overall 601 entries and out of 601 entries, two of them are unique. We understand that we are only having two entries, male and female in the gender. That's why the two is written here. Married, 611, of course. Yes and no. Dependents, 4. Of course, 0, 1, 2, 3 plus. Education, yes. Graduate, not graduate. Self-employed, yes and no. Property area, semi-urban, urban or rural, 3 types. Loan status, yes or no, 2. Now this drop in frequency is telling me the mode of the column. Do you understand what is mode? How do you define mode, guys? If I ask you what is mode, then how are you going to answer it? Frequency of the entry, right? Frequency of the data. It is telling me ignore loan ID because we know that each entry came only single time. Gender, we are having 489 males in the gender column out of 601. Okay. Out of 601, we are having 489 male. Okay. Out of 611, we are having 399. Okay? Yes. Okay. So it is telling me mode. This combination is telling me mode. The frequency as well as the entry of what. Okay. Let's see the frequency of what entry. Frequency of 0 is 345, which means my mode is 0. Frequency of graduate is 480. Frequency of no is 500. Frequency of semi-urban is 233. The frequency of yes is 422 out of 6.4. So this top and frequency is telling me the mode of my data set. Okay. Let's move forward. Let's talk about, suppose if you want to A minute. Yeah. So this is your DF1, and then you are simply writing dot. After that, you are writing describe. Inside that, you are writing include and all. If you notice, if you are going to give this command, it is going to pick up all the features for you. And according to the statistical approach relatable to those features, it will give answer in that particular cell. The rest of the cells are going to get filled with NAN. Okay. For example, loan ID is your categorical type of feature. Okay. Now, in this loan ID, we can see that count, unique, top, and frequency we can only predict. For rest of the statistical approach, it is giving me NAN as the entry. Okay. Similarly, for the numerical type of feature, we can only find mean, standard deviation, minimum, critical 50, 75, and maximum. So it is getting filled here with those calculations. The rest of the entry returned as NAN. Okay. So that is how you can describe the columns as well. All the columns of the data set. Okay. And here your high level understanding data finishes. Okay. These all commands were there for your high level understanding of the data. Now we'll be jumping towards the low level understanding of the data. Okay. Let me put the heading here. Guys, is it looking boring for you? Not fun? Okay. Cool. Now, since we are jumping into the low level understanding, I hope you guys remember that we are going to perform univariate, bivariate, and multivariate analysis from here itself. Okay. When I'm saying univariate analysis, you need to understand that we again have subdivision inside the univariate analysis, which is, let's say, which is of your data type. Okay. Of course, we are going to pick up the univariate analysis, but with that, now it's the most boring. Okay, no problem. Low level understanding, you are having univariate. Okay, this is univariate. We have two different categories of this univariate. First one is your numerical type of data. And second one is your categorical type. Okay, can't help it. You have to. Okay, so univariate, when we are talking about, so we have to deal with a single column. You're getting it? We're going to cover columns one by one. Not all the columns I'm talking about. You can see we are having 13 or 14 columns of blocks. So we are not going to cover each and every column one by one. No. We're only going to pick those columns which can give me some certain insights. Okay. As in, what I'm going to do with the loan ID. Is it going to give me some insight? No. I'm going to ignore that particular column. So whenever I want to find the insight of the data, I'm going to choose some particular column where I'm not sure what type of entries are there. Okay. And I'm going to select that particular column to do the post-mortem of it. Okay. I will understand what different type of entries it is containing, what are the frequency of those entries present inside that particular column, what is the data type, how many unique number of elements are there. Such kind of things we are going to perform under univariate because we are picking one column, and we are going to do the numerical and categorical analysis separately. Okay, we will pick univariate categorical combination on one go. Then we will pick univariate numerical combination on second go. Like this. Okay. So first combination I'm picking here is univariate categorical type of data. Let me write it down. Univariate categorical type of data. Okay. Now, I'm giving you the approach for this, how you're going to do the analysis. Okay. Give me a moment. Yeah. So suppose if you want to identify, let's say, how many different values are there in your loan status. Getting me? How many number of yes are there? How many number of no's are there in that particular column? Okay. So let's say how many customer got the loan. If you want to answer this particular question, can we simply pick up the column of loan status? So what I'm going to do is I'm going to go back. You can see there is one loan status column. Okay. I'm going to pick that column, copying the name of it, coming back here. The name of my data set is DF1, putting the square bracket and pasting the name of my column. This is how you select one single feature. This is one way, and we do have another way like this. So either you can select the column by first choice or you can select the column by alternative choice as well. My preference is first choice. Okay, if you want, you can go with the second choice as well. So I'm selecting the loan status column and simply writing dot value counts. Understand that, guys, we are performing univariate categorical type of analysis. Okay, which means it is going to give me the answer for categorical type of data only. Don't go and apply this value counts on the numerical type of feature. Of course, it is going to work. I'm not denying it, but it is not going to give you any meaningful insight, which means you're wasting your time. Running it, you can see what it is giving me. Yes, 422. No, 192. Could you please tell me the data type? When I'm saying the data type, could you please tell me the dimension? Is it 1D, 2D, series, or data frame? What do you guys think? What my output is looking like, a series or a data frame? Very wrong. Bahut galat. That's why we learned the difference between series and data frame before. Whenever we select one column, it is always going to be 1D. You can see how we fetched the data out from the series. I mentioned the index position, right? Suppose if I mention the index as this, working. It is indexes and values. This is a series. Whenever you receive the answer in the sense of data frame, it is going to look like this. This is a data frame. We can definitely call this as a data frame. You can see it is giving me a proper border lines of the table, names of the column. Do we have any name of the column here? That is the first identification that it is not a data frame, right? If you see the column name here, then you can say that it is a series, it is a data frame. But right now I can see we don't have any sort of column here, which means it is a series identification. Okay. Now, If I ask you the same question, that what is the percentage of customer who got the loan? Now, guys, you can see that we are having the answer of 422, right? The question was how many customer got the loan? The answer is 422. Now, if I say how many percentage, what is the percentage of customer? Of customer who got the loan. Coming back here, simply can I write DF1 of the loan status again, selecting that particular column, writing the value counts again, no difference. Simply writing normalize is equals to 2. This will help you to convert your values or counts into the percentage format. Okay, whenever you mention normalize equals to true inside the value counts, it is going to help you to convert your numbers into the percentage. Now, if I done this, is it giving me the answer in the format of percentage? No. You have to multiply it with 100. Okay, so 68.72% of yes are there, and 21.27% is no. Okay, now you also get the answer of yes and no. How many percent got the loan? How many customer got rejected from the loan? Bar graph, pie chart, histogram, line graph. Okay, and scatter plot, box plot. Yes, bubble plots as well, but that is what we are going to learn in advanced libraries, okay? And there is one more graph called as KDE. Okay, these all graphs we are going to cover in pandas. Okay, just a basic. We'll talk about that. Kernel density estimate. The full form of KDE is, let me write it down. Kernel density estimate. It is a type of a graph that helps us to judge the outliers. Okay, so that discussion on outliers we are going to have tomorrow, not today. Okay, so the basic thing is that we know how many graphs are there, but we don't know which graph to create at what situation. Okay, that is what people fails to understand. Remember maybe. So according to this understanding of your data set, low level understanding, univariate, bivariate, multivariate, we are going to create graphs just to let you people know that in what condition, what type of graphs are suitable. Okay. Here you can see I want to distinguish among two values of a single column, right? I want to show how many number of yeses are there, how many number of no's are there. So whenever I want to distinguish among two values of a single column, I always go with bar. These two are perfect graph for the creation or for the distinguish of the values. Okay. How we are going to create it? That question. Very simple. Pandas have this method called as dot plot. Do you guys understand that bar graph is the combination of one categorical feature and one numerical feature? In this series, you can see we have a category here and we have a number here. Can I simply write dot plot kind is equals to bar here? What I'm doing, first I'm selecting the column loan status. Okay. You can see DF1 loan status dot value counts. What is DF1 loan status? I'm selecting that particular column. Dot value comes is helping me to convert the entries of that loan status, yes and no, into the numbers. Dot plot helps me to plot the graph. Kind is equals to bar help me to create a bar. Okay. Now, guys, this type of graphs we never use to display in front of clients because it is not visually appealing. Okay. We do have advanced libraries. This is just for the analysis or exploration purpose. Okay. So later, if you come back to the notebook, you don't look into the numbers. You just see the graph and understand, okay, this is what inside the loop status. Getting me? You can see the proportion. You can understand that number of years is quite high as compared to the number of no. Okay. If you want, you can create the same graph, or let's say, same calculation or same distinguish of entries with the help of pie chart. So kind is equals to pi, you need to write here. You can see it is giving me the loan status, yes and no. Understand that I'm again repeating, it is not the kind of a graph which we are going to display in the front of clients. It is not visually appealing when I'm saying this, which means in the sense that we do not have scale here. I cannot see the number of percentage in the pie. I cannot see the x-axis and y-axis name or label properly. I cannot see the name of the graph. If I want to change the color of the bar, it is not possible as well. So these are some of the disadvantage while we create the graph with the help of pandas. Okay? So we only create such graphs for the understanding purpose, for the visualization purpose, for us on doing the analysis. Okay. You can also create this type of graph for the gender feature, all the categorical features. Okay. There is no restriction for that. You can pick up any combination which you want. Now we have to jump into univariate numerical type of data. Okay. That will be starting from tomorrow.